you.
Okay, then we soon will let David explain how to kind of get rid of Android if you feel like it and run some real Linux on it. David, off to you.
Thank you. Yeah, so thank you for everyone turning up. It's a nice turnout. Basically, if you're here and kind of reading this slide, then it's not going to be a surprise to you that these things that we've got down here are not running Android. These devices that we've got are all running Linux. So they're running a glibc stack, things like Nexus 5. That's a Nexus 5. They're all very oblong. Watches, tablets, that kind of stuff. It's a very open glibc stack, GNU Linux if you prefer. And it's actually based on Mare, our OS. And this is Yola's device. This is our first one. And although it's a dedicated Linux device, it comes with an Android BSP, a board support package. So yeah, all these things are running Android, come with Android, but they're capable of running our Sailfish OS and Mare. And probably worth telling you a little bit about who I am, where I've been. Been around for a while. I used to work all over British Telecom. We eventually moved to work for Nokia via kind of doing some open source stuff in MIMO. That then turned into a project called MeeGo, which you probably heard of, but that one didn't end well. So two of us kind of looked at the pieces that were left after MeeGo and decided to pick it up. And actually, that's a really important point. We've kind of got to say thank you to Intel and Nokia for doing things in such an open way, because they didn't waste all that work. So we trimmed that down and set up some infrastructure and resurrected the Mare thing that we'd gotten going in MIMO times. And that's kind of that's how I kind of got into this area. So I work at Yola now, and I do systems and infrastructure stuff around the Mare project and that kind of stuff. And I'm working on some hardware documentation, hardware adaptation documentation. Questions and stuff, if people want to ask questions, just yell. And if I need to defer them, if I'm going to talk about it later on, I'll just say so, and I'll say I'll talk about it later. Okay, and this is not actually a Yola pitch. I've got the T-shirt, and Yola are kind of involved in what we're doing, but really it isn't. I'm here kind of more as an open source person who works for Yola. I'm not emphasizing Sailfish, because it's actually not a fully open solution, but most of it is, and I'm going to focus really on the open aspects of what we do. And it's also a really good case study. It's distributable enough that you can use it, and you can go and download images and put them on your Nexus 5 or Nexus 4 or whatever, and all the other various ports that we'll talk about later. It's pretty fully featured on those devices. And frankly, it's one of these things that you get proud of. I'm kind of proud that we took this thing that they dropped on the floor, and eventually, a little while later, we've got a smartphone on the market that's running a real Linux. This is a hell of an achievement for a company of 90 or so people. And it brings some credibility and a real sense of pride that Mare's actually been able to do that. And what we've done is we've kind of got this Sailfish for Everyone program, which is what it says it is, kind of fairly straightforward. We work in the open on this stuff. And we've got people down here who are kind of our porters and everything, mainly on IRC, and we work on these various devices. And the idea really is to help people get this build onto their devices. And that also works for other types of OS as well. So we can put different root file systems on there, which we'll talk to. And a lot of it is about guidance about getting the layering working correctly. And I'll talk about Haddock, which is, we kind of got this nautical theme going, and then where is Tom? Around here somewhere, decided that Haddock was a really good synonym for the hardware adaptation development kit. And that's kind of what's in it. That's the table of contents. And the whole thing, I printed it out for a talk once. It's a great big thick piece of paper, but we've got it. It's on the web, and it's a lot of cut and paste level detail on how to get a build of Sailfish onto another device. And that's kind of the goal of this development kit document, is to enable this kind of Mare-based distributions on top of the other devices. New devices need more effort, so things like the smartwatch and stuff, we kind of got to wait and play around with the OSP. I'm hoping that somebody here is going to help me from Sony, but we'll see. But one of the principles I've kind of got with this in this area is that with open source stuff, it's great, you can do the work, and I've gone along and I've seen YouTube videos of people who've done ports. But in my opinion, the work's not done until somebody else has come along and replicated your work. You know, it needs to be something that somebody else can build on. And that's, again, a lot of what we're about, getting other people to be able to do this. Okay, so the technology that we've got, a little bit about the operating system behind the devices. And really, you know, the best place, I think, to start for this is the foundations. We're talking about eventually getting Android off of a device and getting a Linux-based system onto it. So it's good to know what that kind of consists of. As I mentioned, Mare is at the core of Sailfish OS. And the heritage, this MIMO times with Nokia. MeeGo offered the same concept, really, that Mare was trying to do with MIMO, which was essentially to show them how to open things up. MeeGo kind of came along and said, right, we're going to do a fully open OS. There were some problems with the project structure, but the code was open enough, as I say, that we were able to pick it up. And today, it's this core distribution. And that's really the way we look at it. It's not a fully featured system. I've talked in the past about comparing it to Debian with thousands of packages. Mare actually just has about 400 or so packages. No applications. You know, and I kind of do some stuff with OpenSUSE and things, and they have this JEOS, just enough operating system. And in essence, that's what Mare is. It's just the core. You know, and many of you use Linux distros, so the kinds of technology that we have in there should be familiar to people. I mean, it's like the talks that you see. Almost everybody here is going to be familiar with almost all of these technologies, from your desktop type systems moving over onto devices. Some will inspire deep opinions, and you will love or hate them, but frankly, some of these technologies, we've picked them, you know, and there are alternatives, but we've picked them because they really work well for our use cases. We're pretty happy with, actually, systemd is a good one for us, but it goes for others as well. If you don't like them, that's okay. It's all open source. You just build and use this stuff, and you're quite free to kind of change various bits and pieces as you like, or use something completely different. Anyway, that's the Mare core, and that forms the basis. But we know that what we're going to be interested in is producing devices that people are going to be using. So having a really beautiful user interface is important to the people that are going to be using Mare. Actually, one of the things I didn't say is that Mare's kind of vision statement, a kind of, you know, what are we trying to do? We're trying to make it easy for vendors to make devices. And that's actually quite important to understand. We're not here for users to hack on Android. We're here really, and we're trying to structure ourselves as something that companies can come along and pick up, and they can actually use that to make devices. And as a community, we can contribute and become part of that. So yeah, when they make the devices, they're going to want really nice user interfaces. And Qt is basically the technology that we like there. It's a really important thing. We're using about 5.2-ish of Qt with some 5.3 and even 5.4 parts of it backported. Yeah, we're doing Android, so I'm kind of saying we don't use Java much. When you go to things like XDA, DevCon, and they're all full of Java people, it's kind of interesting. But yeah, QML is actually probably the single strongest point of what we do. We really like the way QML works for creating user interfaces in this kind of space. It's a declarative system, and it's really easy to start prototyping stuff. And if you've got some kind of good design people, graphic design people, you can work closely with them and start pulling these UIs together really well. You know, the Sailfish UI is an example of that. It's absolutely gorgeous. And it really does give you this rapid UI development, but it also gives you another architectural thing, which is the separation of your user interface and the middleware as well. So the Mare core and the areas around there can start having really open bits of middleware, so that the vendors and such are really focusing on the differentiation in the user interface layer And that's a good thing. Technology, so if we start looking a little bit at what's going on, this is the Android stack, and this is kind of where we start to look at how we're going to be getting in towards the Android side of things. We've got things like Qt Wayland replacing Surface Flinger. We kind of have the hardware composer in there that we're using a little bit, but not a lot. And this should be familiar to them. It's one of these where it was an Android slide, so it did come complete with a typo. And it's actually interesting, you know, getting fixes back into Android and all that is not the easiest thing. So again, that's a different part of what we do with Android. So yeah, we render to textures and compose that using GL, and that's all part of what we do in the Qt layer. So why are we kind of focused on, if you guys want to come in and sit down, that's cool, just wander through. Why are we focused on this Android side of things? Well, because blobs, we're all familiar with binary blobs, pretty much from the kind of the desktop environment where you kind of get the GPU variant for things like the NVIDIA drivers and such like. I'll come on to that soon, but it's about understanding that this stuff is what's happening in the low level, and we need to interface with the Qt stuff and the glibc stuff later. Another thing with Qt is it's quite big, but it's become a lot more modular, and that's important for being able to manage change to it. Okay, another side of what we need to do, we're all going to be hopefully looking at putting this stuff onto your device. That's going to involve development work. So I'll talk a little bit about the SDK side of things, just to kind of give you a perspective of what's going on there. I will talk more about the actual details of it later, but essentially what we've got is something called the Mare SDK. Very clever name, that. And essentially, it's a chroot. We take a copy of the Mare OS, we run it as a chroot, and that means it runs on all distros. And that means for us, that's pretty much a very low support cost. And then you can play some other little games. If you put it in VirtualBox, all of a sudden the SDK now runs on Windows and Macs too. And you know, you can do things in there like you can share the file system of the host OS with the VirtualBox, and that starts to integrate nicely. We mentioned we've got Qt, so that means we've got things like Qt Creator. Qt Creator, actually, because it's Qt and cross-platform, runs natively on Windows, Mac, and of course all the Linuxes. So now when you've got this stuff, you can start to link these things together. And what you have is fairly well integrated, but relatively trivially supported SDK environment. And then we can do a few other things, like we can run a web server in that virtual machine I mentioned, or such like, and we start getting management capabilities in there. Again, all relatively easy to do and relatively well supported. So efficiency is quite important when you're as few as we are. The other thing that's worth mentioning is that self-same core, that SDK, is, as I say, it's just a copy of the OS, really, with some tools in it. And I mentioned OpenSUSE, and one of the reasons we're close with them is because they have this open build server. And that's a really powerful build farm capability that's able to build lots of different distros. And each time we look at what we're doing, we're essentially building a distro here. And we've kind of taken the way that works, and we use the OBS as part of our kind of processes, if you like, for building both Mare, for building Sailfish, and for generally being able to do quality assurance and kind of the development cycles through this kind of area, QA and such like. Again, that goes back to the fact that Mare is all about providing this level of sophistication for vendors who want to be building this kind of thing. Bit of off topic. However, yes, the subtitle of this talk was rooting around the breakage of closed binary blobs. Because, you know, we're aware that there are people out there who work on open hardware. And frankly, if there's any of the guys in this room who work on open hardware, it's like, thank you, because the work they're doing is really impressive. It's very, very difficult to do. It's not yet at the level where it's on, you know, it's not functionally comparable to the stuff happening in the proprietary world. And we're looking at the closed hardware side of things. And I think we're doing that with the attitude that says, let's get ready for a more open environment. Let's get ready for having decent open hardware. But if we sit around and just wait until open hardware has caught up with closed hardware, we're going to be waiting a long time, and everything else is just going to kind of carry on apace. So we can't really afford to do that. So we're taking kind of the same approach as the kernel did with NVIDIA. There's this kind of support thing with them, and keep the pressure on, frankly, show what we can do with this kind of device, show the innovation you've got when we're able to hack on them. And pressure does work. You know, you look at AMD and the way they've started to kind of open up some of the drivers and things, and you know, some of the other system-on-chip vendors are beginning to start with these open source initiatives. So we think that this is a relatively sane, but not necessarily kind of free software purist approach to this problem. And yeah, the solution that we've got in this routing problem is something called libhybris. And it's essentially because vendors nowadays, when they're looking at this hardware, they go and create an Android board support package first. And that's what they do. That's what you get given. And again, the problem here is that the user space blobs that they supply with you to, they support like the GPU, the modem, the haptics, sensors, camera, GPS, all that kind of stuff. They're all linked against Bionic. And I think I mentioned that we were doing glibc and stuff. So that's a bit of an issue. And what we need to do is we need to kind of get something which links together this Bionic space driver with the glibc environment. So basically, that's what libhybris is going to let us do. So it's essentially working in the kind of linker space. And a linker has kind of three kind of key functions that you're looking at. DL open, which lets you dynamically open and load a library. DL sim, to kind of find the address of functions. So it gives you a function pointer. And once you've got that, you can then call it and execute it. And DL close is probably the other one. And what we've kind of done, Carsten did, is decide that actually this was a perfectly sane and sensible thing to do. So a bit of renaming of these functions to Android DL star to avoid collisions with, you know, actually wanting to load shared object libraries in the glib space. And when you do that, yeah, it turns out you're running Bionic and glibc in the same process address space. And you might expect this to be seamless and just simple. Or if you've thought about it, you might not. It wasn't actually that bad, but yeah, there were some tiny, scary issues. But the key thing is that nothing actually blocked this. After you kind of went through it, at the end of the day, it's capable and it works. There are a few areas where there are bits of problem, but like I say, nothing fundamentally blocked what we were doing. You just have to do some hacks on some Bionic headers and things like that, some changes of some definitions, but basically it works. So yeah, I mean, the actually way it opens is you kind of open a shared object library. You say, okay, give me back a pointer and call the pointer. And if you create this kind of functionality, then that becomes a typical wrapper for your, what's that one, EGL kind of capabilities. Some of the wrappers are a bit more complex, and some of them have an awful lot of function calls, and some guys have done some really interesting work that looks up this kind of virtual table lookup thing, which was quite interesting. But essentially, you do that for your EGL, and then you kind of rinse and repeat for whatever other libraries you've got access to. Okay, so moving on from this, we've got these, recognize that sound. We've got these that we need to work with. A lot of people out there are already working on providing access to the devices. And CyanogenMod is the key area where people are doing this kind of stuff. So what we did was, rather than say, okay, let's go and start a new thing, we're kind of working alongside the CyanogenMod people and saying, okay, if you can run CyanogenMod 10.1 or 11 on Nexus 5 and stuff like that, then you can work on the device. It's a bit complicated. Well, it's a bit detailed. So the idea was, as I say, we want you to be able to hack on it, and the instructions really is what the haddock is about. It's about going through this and trying to describe roughly, when you go and look at the detail, this will give you a kind of an overview of what this is all about. So yeah, the first thing you kind of get is you get this platform SDK. As I mentioned, it works on pretty much all the Linuxes, it works on the build farms, and what it's doing is it's providing a framework for you, and for us, it's going to provide the actual SDK itself, so you've got things in there which are typical tools. Something called Scratchbox 2, which is our technology for essentially cross-compilation. Haven't really got time to go into how that works at the minute, but questions are welcome. Scratchbox 2 then looks at a device target, and I'll explain this in a bit more detail, and says, okay, for a device, I can actually start building binaries which are compatible with that target. We've got image building tools inside the SDK as well, so people will probably be familiar with Make and Kickstart type capabilities. OBS tools for interacting with the OBS if that's something you want to do, although you can do all of this just on your local desktop. There's a minimal Ubuntu setup in there because Android likes to be built on Ubuntu. And then you've got, on device or the emulators, you've got other tools that you can start running, so debug tools, LA-Trace, PowerTop, Valgrind, that kind of capability as well. And I hope you can see the coloring on this. There's a lot of nesting going on in this. On the outside, well, yeah, technically you could run this on a Windows machine and then start using virtualization inside, but let's just assume you've got a host OS which is Linux. And inside that, you run the Mare SDK. And that's basically, when we get into it, that's where most of the work's going to be done. And that is the bit that's going to be common to everybody. And that means our support issues are minimal, as I was saying before. Anybody can come along to IRC and they'll say, oh, I've got this. And instead of saying, what distro are you on? What version of what distro are you on? Ah, well, you're going to be using that version of GCC then, and that's not going to work, sorry. We just have this standardization in the SDK. It's got this thing at the side, which is the hardware adaptation build SDK. We try and just give them names just so that we can actually consistently refer to them in the documentation. And that's the minimal Ubuntu thing. And essentially, it's got enough in there for running repo and things like MKA, which is the CyanogenMod make. Yeah, and each device will have a manifest which will be built in that area. I'll talk about manifests again a little bit as we get onto that. Then we've got the SB2 device target, and this is where the architecture specific stuff comes in, most of which will be ARM, but we are building against Intel Android as well. It is actually device specific because we're doing hardware adaptation stuff and we're going to install device specific header files into there as well. So we create one of these targets per device. In other environments, you actually don't need to do that if it's like a nice generic thing. Yeah, and kind of a hint, you can have multiple devices. There's nothing wrong with having multiple device targets running alongside all of this. Putting them like that is quite nice to be able to develop against multiple things, or to use different versions of QA level. So yeah, the first thing you do, you install the Mare SDK, and that's basically, you get package manager stuff in there, the development tools, and at that point you're ready to cross-compile. You install the HA build stuff, and then at that point you're kind of sitting there, you've got the bit where you kind of, you pull in the repo stuff and start compiling that. And once you've done that, yeah, sorry, now you pull in the repo stuff, and you start getting the source pulled in. That pulls in from Git, and basically you get the repo, you tell it to pull the stuff in from Git, you type make, and if it's a supported device, you get a load of binaries built, okay? And what you've basically built is your Android core. So you've got things like the system stuff in there. You've got the kernel. you've got init, some odds and sods of tools binaries, bionic, various bits of Android shims and stuff, and some config. And all that comes from this manifest. A typical Android manifest pulls down an awful lot of source. So rather than say, okay, we'll do this and build Android, what we do is we say we'll trim out just those bits which are relevant to the hardware adaptation level. And actually, that's something which we're starting to make easier. So if you do come up with a new device, we've got a list of areas in Android that are kind of really essential. And then you start having to do the build and say, all right, it fails because this is missing. And that's because your vendor requires this bit of device source as well. So you add that to the manifest, and you basically keep working that through and working the dependencies through on this manifest until you get it all to build, and it's as minimal as possible. That manifest is essentially a list of Git repositories. So when you're hacking on this, you're going to be working with a lot of these things which are essentially the community shared repositories, the upstream basically, and then you'll have your own forks. So the manifest might contain stuff that you're hacking on because you find out, I actually do need to change this. So the manifest lets you work with both standard Git repos and your own version of them. And again, if you're actually working inside an organization doing this kind of stuff, then the manifest is likely to point to your internal copies of these repos and then to yours as a particular development or development team. So yeah, once you've built these, boot and recovery image stuff too. Once you've got these things built, we're talking about now putting a standard Linux environment on top of these Android devices. So, we use RPMs. So we need to put all these things into something that will allow us to manage versioning of these. If we find a little bug in something, we want to put out a new RPM that contains a new version of, I don't know, Bionic or the config or something like that. So the next thing to do is to actually start creating, in the Haddock, is to start creating the RPMs. Relatively simple step. And having done that, we're at the point where we've now got something which is ready to install. However, we've only built the Android stuff. This is the stuff that kind of comes and is ready to run on the device. We've got to build now the shim layer that sits between all the kind of low-level Android bits and pieces and the glibc cute kind of areas, pulse audio and that kind of stuff. So all the work we've just done has been essentially in the Ubuntu environment. We've gone in, we've gone into repo, we've pulled in the source, we've typed make, and it's all come through. We've kind of just popped out and just packaged that all up. And what we need to do now is move back into this kind of more Linuxy space and say, okay, let's install the header packages we just packaged up. Let's install them into the target. These are Android RPMs, they're ARM, so they'll go into the ARM target. And what that means now is that we can start building our drivers, and they will use these development headers. So again, this is why we end up jumping around. When you go through the documentation, you kind of, some bits are done here, some bits are done there. It's because we've got some of the stuff being developed, if you like, in the Android space, and some of the stuff is being developed in the kind of more Linuxy space. Yeah, and essentially what this is just doing is using the HAL, it's shimming onto the HAL API from the Linux space. So, right, okay. Talking a lot. You've got a kernel, you've got some drivers, you kind of now need a bit more of an operating system. And that's where the next step is to sit there and say, okay, well, we could actually do with some functionality, something that actually does something. And we use a tool called Mick, which again, I think it started off as the Moblin image creator, then it became the Migo image creator, and I guess it's now the Mare image creator, but we haven't actually changed the name of that, so anyway, it's called Mick. And basically what it does is it makes an image, a file system image for you that you then need to get onto the device. And actually, that's the point here. This is just a file system image. it's a root file system. It doesn't have to be Sailfish OS. You can put anything on there. Nemo, we can create Nemo kind of root file systems, a minimal Mare root file system that does very little, but you can SSH into it. You can put different distros on there as well. Or probably of more interest is to go in and get this minimal Mare distro with just Qt, and also your app, whatever it is you're doing. If you've got one of these nice low-power dedicated devices that will just sit in a cupboard using hardly any power but give you a nice Wi-Fi connection and survives a power cut quite nicely for a day or so, these things kind of become quite useful around the house. I'm working on some Internet of Things stuff because, who isn't? And I'm using Spark because I really like the kind of open firmware stuff that they're doing. I've got loads of Spark things hanging around the house at the minute. I want to do this with a tablet in the kitchen because, again, that's never been done before. And actually, because I really want a kitchen-based shopping list. But now what I can do is I can kind of write a pretty small app that's got connectivity back to my home servers or my phone or whatever, and actually start to build that realistic for myself. I want a car stereo because I actually quite fancy running, OpenStreetMap on a Nexus 7 or something and just, nicely fitting it into the dash. There's a lot of things you can actually do with this stuff, and that's kind of the point of being able to reuse these things. Now that you've got access to the 3D graphics, the Wi-Fi's, you've got access to the modems, you can play with some quite interesting hardware and do some quite innovative things. So yeah, basically, building that root file system is where stuff, to my mind, starts getting really interesting. Everything up to there is just an enabler, and depending on how interested you are in actually either hacking on the hardware or doing something with it is where you're going to focus. Right, and then you flash it. It's Android, so you're using ADB or Odin or something for some slightly different OSs. But essentially, flashing it is just the step of writing it onto the device. And then you boot it. And then you get a black screen. I wonder what the hell's going on. Yeah, that happens as often as you would expect. So it's kind of interesting to understand what happens when you boot. You basically need to understand that it goes through a bootloader first, and we're talking open devices. So there are devices out there that you can't really get into, but as I say, if you're looking at CyanogenMod, these problems and getting through to this levels of steps has all been solved. So your bootloader starts up. Be aware that sometimes your bootloader contains the kernel command line with hard-coded kind of things in it, so you might have to play some silly games if you want to change kernel command line stuff. It boots into the kernel. The kernel is typically provided, we use an initRD because it gives us some ability to interact and provide a minimal environment that works. initRD then jumps into init and systemd. Systemd then kind of starts up and goes through its dependency things. And one of the systemd services is actually the Android init. And that then starts up some of the Android bits and pieces that still run, because as I said, there's some Android binaries that you build that are still quite useful. So that's what should happen. And systemd will also be typically starting any graphical environment which will put the display on and start running user sessions, which is typically where you're going to start running your actual applications. What we've done is we found that this was, as I say, a bit error-prone. So early on in the initRD, we'd run things like a telnet on the USB port with USB networking and that kind of thing. But the other thing that's quite cute is that these devices act as USB gadgets. So when you plug them in, they have a serial number and they have this little description of what they are. And actually, it turns out that serial number can be anything, and so can the description. So during the init script, what you can do is you can just write error messages into the serial number. So if you write an error message into the kernel USB gadget serial number and messages, what happens is you go to LSUSB and it kind of says, I stopped here. And that's really, really useful, okay? So that kind of capability is I mean, it's just a little hack, but actually when you're trying to work on these things, that little bit of where the hell did you stop? Yeah. So things like that, just tricks and stuff is what the kind of porting team is like there to help you find your way around and figure out how to use. And then pretty soon after that, you can telnet in. It opens up a standard telnet port because, you know, we're not going to assume anything as crazy as SSH is going to work. So yeah, you telnet in, and at that point then you can sit there, and you're typically in before init starts. So we start this, you telnet in, and then you tell it to whatever flip route and start systemd. So you can manually start in, PID 1 and watch that start to execute, which is also kind of nice to do. Right, what's next? Yeah, and that's it really. Once it starts to boot, once it starts to run systemd, you can start running anything you like, and then the typical SSH stuff. Yeah, I said Node.js. My Spark stuff runs Node.js, as it turns out. So, you know, the point is that this is now a standard Linux distro. It's none of this messing about with, oh, can I actually build this thing for, you know, Android? I don't need to. It's just Linux. So, yeah, it runs Emacs, of course. I mean, that Emacs is on the phone anyway, so that's absolutely fine. But your typical, you know, you go in /configure, make, and everything kind of just sits there and works. Right, where else? Yeah, the community around what we're doing, the Sailfishos Porter community, many of whom are kind of hanging around here, this is probably your slide, actually, I think, is it? Yeah, it is. Cheers, mate. So there's about 25 or so developers kind of working on this, and we have a number, probably more than 22 now, of devices that are being worked on. Quite a variety. The Nexus 4, Nexus 5 are probably the ones that are that we spend most of our time on, because it helps us as well to be working on this stuff with the community. So we kind of put some work time into doing some of this as well. Yeah, probably not. There's Intel stuff on there as well, isn't there now? We're working on that. Yeah, this is the what works and what doesn't matrix. I think the nice thing is that from a functional point of view, there is green in every single column somewhere. So I've got to say that look, you see, that's the one. That yes in the camera for the Nexus 4, I think, is like, whew. But yeah, every single one of the columns has got green in it somewhere. But clearly, there's work on all of these things that needs doing. There's bits of hackery that needs doing, and some are more difficult than others. Camera's a particularly tricky one because the vendors play in that space quite a lot. Basically, just a random list of things down the side, and you can kind of see that some of the particularly green ones are actually definitely usable as a day-to-day phone. And this is talking about Sailfish status on these phones. So that, I mean, Sailfish uses basically open middleware. So all the middleware stuff works on here. And then the UI stuff, if some of this stuff you might have to write UI stuff for as well. But yes, lots of red, lots of green, lots of devices. I think I skipped one, did I? Yeah. I mentioned, again, another Martin slides. I mentioned that we've kind of been working with CyanogenMod. And there's quite a lot of activity in the Android space. They're beginning to become more familiar with what open source actually is. So they kind of, there's people out there who are really familiar with open source, and there are people out there who are just kind of, you know, share the code without particularly thinking about licensing and what they're doing with it and that kind of side of things. So multi-ROM is one of these kind of multi-boot capabilities. So you could be talking about having bought a cheap device on eBay that you've just kind of dedicating to running Linux, or you could be wanting to multi-boot something as part of an experiment and what have you. And it's nice to be able to use this kind of stuff to say, well, actually, I can multi-boot, and I can sit there and run both on my device. And worth mentioning that we're working with upstream as well. So just one of the problems, I believe, yeah, in the N5 port, wasn't it, you were saying, that essentially we found a bug. It was a genuine bug, didn't impact CyanogenMod, but they accepted it was a bug. So, you know, the patch was accepted, and it's kind of nice that they kind of took that in for us. And that just makes our life a little bit easier because we don't have to carry bug fixes and patches. So yeah, a lot of this then becomes about, you know, talking to us. Overall, there's a lot to digest in what I kind of just went through, and I delivered it pretty kind of quickly, and you need time to take it in, and then you need to start asking questions about it. There's kind of initial work in XDA. It's actually a good place to go to start looking at how to get onto specific devices and looking at which ones are easy to get access to. And then our work is primarily done, there's a Sailfishos Porters channel, which is where we kind of hang out and talk about essentially the bits and pieces about getting, say, hybrids compiled and doing the work which is about getting onto a device. I don't think it's on there, but things like actually going into hacking on particular packages like Hybris, there's a channel for that as well. There's the Mare channel where we start focusing on the actual Mare core side of things. So yeah, there's a few IRC areas. There's a lot of the source for this stuff is on GitHub. The Mare stuff is on a Git server on the Mare project, and we will be moving around between the two of them, but we'll let people know. It's actually quite a friendly community in terms of genuinely meeting and talking to people. So we do the meetup type thing and try and get together in person from time to time. We're doing stuff. There's actually, we're more kind of doing Nemo and Mare stuff this afternoon, aren't we, than Sailfish Porters, really. But we kind of get together and we'll talk about porting stuff as well. Real meetups. And yeah, we have the IRC meetings as well, just to kind of make sure that everything's on track. We try and do triages when I kind of turn up for them. You know. But yeah, they kind of work quite well. What else? Yeah, the Mare project itself is where most of the Mare open source work is done. And you know, I've already said that the vision statement, make it easy to make devices. So there's a lot of stuff happening around there. And the idea is that there's core and some middleware there. The Nemo project was where the middleware stuff has been working at the moment, and we're bringing that back into the core. We're going to be talking about that this afternoon in our BOF session. And I think, you know, there's the system stuff around Mare as well. There's things like build servers, working with the Bugzillas, working with some process automation and QA type things. Basically things like Git hooks and automated builds. And there are quite a few more facets too that I haven't really got time to cover at the minute. That, you know, the fact that Mare is built as a distro and isn't just a huge source blob which you build as an image and ship to a device. So from a kind of a device perspective, doing upgrades by just upgrading RPMs is, yeah, there are people doing experiments with other ways of doing software support and versioning, but it's actually a reasonably well-proven one, and we're using quite established techniques there. Best practices and documentation, and this whole thing about, you know, we need to deliver more than just code. We don't just chuck the code over the wall. It's all about trying to say, okay, this is how it works, and this is what we're doing with it. Okay, basically wrapping up to say that come and port Mare and Sailfishos to your device. Like I said, please come and help make cameras and stuff work. Write new UIs, kind of experiment with things, and if anyone can get, you know, things like that, what's called OpenStreetMap and such, like working on those devices, that would be rather cool. Working with different devices, you know, I'm really looking forward to seeing what we can do with things like watches and such. And another thing just to kind of wrap up with before I start asking for questions is, yeah, Yola have kind of said it's likely that people will want to use Linux phones. So there's a discount code for FOSDEM, special one, and you get a €50 discount for the next week. If you go along and type in FOSDEM 2015, we ship to EU, Switzerland and Norway. And there's this tablet thing that we're doing as well, which is basically an extension of this kind of running a glibc Linux stack on top of these devices. Right, so I think that's actually 45 minutes, that's not bad. Thank you. So, are there any questions? No. Everyone's gone. Any questions, and come and talk to us.